Guys, welcome back. This is Mr. Morales, and this is the first set of notes on a new lesson. Today, we're going to be discussing the cubic function, or basically the graph and the current function of y equals x to the third power that we see over here on our left side. On the right side, I have a picture of the graph already, but on the left side, we're going to work on deriving it and explaining it. So we're asked to first make an xy table. So in order to do that, I'm going to go ahead and make 3 columns, x in the beginning, y at the end, and in the middle, I'm going to have the function x cubed. All that means is that I take x and multiply it times itself twice, and then times that same number again a third time. And I'm going to go ahead and just pick some pretty basic numbers now. I'm actually going to do something that we don't typically do, and that is I'm going to use some decimals, and there's a reason for it. So let me go ahead and begin with a very simple number, and let me begin with 0 here. Let me go ahead and throw in, let's say -1 up here, +1 down here, -1/2, or -0.5, and +0.5 right here. Now, x to the third means you take whatever number you have for x, let's say 0, and multiply it times itself 3 times. So 0 times 0 times 0. That would give me a 0. So I know I have a point right here in the middle. All right, now let's go ahead and go to the -1 on the very top. -1 to the third means -1 times -1, which is a +1. And +1 times -1 again will give me a -1. So I get a point over at -1 and -1 right here. And then if I go to +1 to the third power, that means 1 times 1 times 1, which is just a 1. However, this graph looks a little misleading. It almost looks like we have a straight line that's going to go right through. So let me go ahead and use these fraction points. So -1/2. -1/2 is the same thing as -0.5 times -0.5 times -0.5. When you do -1/2 to the third power, you get 1/2 times 1/2 times 1/2 negative, which is 1/8. This is when you're going to want to use decimals. And we're going to have -0.125. So decimal first, 3.125. So it's a very small number. And we get the positive version of that over here. 1/2 times 1/2 times 1/2 is 1/8, which is 0.125. So at -1/2, if I go left half a square, I'm only going to go down 0.125. So about right there. When I go positive half a square to the right, I'm only going to go up 0.125. So what we get is this slight curve. And that was kind of the idea I want to get to you. The line will continue to shoot up, going to the left and right and shoot down. But I want to show that what you have here is a curve. It's not a straight line that connects diagonally. So just at these points alone, I can see how I get the graph over here on the right-hand side. So the parent function of y equals x to the third is this nice little curve that goes from the bottom left, rises to the origin, and then continues increasing up to the right. Now, we are asked on the bottom of this to describe its domain and range. And this is actually really easy with cubics. The domain, from left to right, it starts from -infinity, and then as it goes to the right, it goes to +infinity. Another way of saying that is all real numbers. Now, as far as the range is the y values. Well, if you read the graph from left to right, it goes from also all the negative numbers up to 0 to all the positive numbers. So it too is also all real numbers. So for this particular graph, when you read it from left to right, the domain and range are all real numbers. So for this set of notes, although we're asked to find the domain and range many times, I'm really not going to address it too many times. I'm going to focus more on creating the graph and explaining the translations and transformations that happen to it to the parent equation. So here's our basic introduction. Our cubic graph, x to the third power, is this kind of S-looking shape that goes through the origin. It comes from the third quadrant, goes up to the origin, and then goes up to the first quadrant. It does continue expanding left and right infinitely. It does spread out if you keep going far enough, and it does obviously go up and down forever. That's why we have all the real numbers for the domain and range. Moving on to the next page. Now here we talk about the transformations. Just like all the other parent equations, it behaves the same exact way. If you take your x value to the third power and you add or subtract numbers, When you subtract a number, it moves stuff to the right. And when you subtract numbers, and when you add numbers, it moves stuff to the left. So plus makes things move to the left, and subtracting makes things move to the right. It shifts things over. When you have a number added outside parentheses, just the way you see it, if you're adding a positive number, then it's going to move up. The graph will move up. If you subtract a number at the end outside parentheses, it'll move the graph down. And then we have some other effects. If you're multiplying the parent equation, if there's another number in front of x that's bigger or greater than 0, what you get is a vertical stretch. That means it pulls the graph from the top and the bottom. It pulls it until it starts making it skinnier or thinner. That's what we call a vertical stretch. If you have a number smaller than 0, that's still positive, like 1/2 or 1/3, or a fraction basically, that's in front of your letter A, like let's say 1/2 x to the third or 1/3 to the x third power. What's that going to do is going to make it wider. It's going to push it down from the top and the bottom and squash it out to make it wide. And then finally, if you have a negative something x to the third, it could be a negative fraction, a negative number, whatever it is. If you begin your equation with a negative number, then what's going to happen is your graph is going to be reflected. So if you look over here to the right-hand side, we have two graphs, to draw there, that are in red and blue here on this video, or on this, in this video. So here's x to the third right here in red. It increases, hits 0, and increases and keeps spreading left and right. Then we have negative x third. Negative x third is the one that's in blue. And it comes down from the second quadrant, hits 0, and then goes down through the fourth quadrant. This one actually decreases if you read the graph from left to right. It goes down 0 and then down into negative infinity. So that's the only difference. The graphs are otherwise exactly mirror images of each other, just different positive and negative values. Now let's get into what this lesson's about, and that is some of the basic operations. So on the left side over here, we have our basic graph of x to the third power. That's this middle one that's red in the middle. So this one that's red in the middle, this is our x to the third power graph. Oops, didn't mean to do that, sorry. Here we go. So this is x to the third. When you have a number in front of x to the third that is a fraction or smaller than 1, you get a wider graph. So this green one is going to be the 1/3, whoops, I need to lock this down, 1/3 x cubed. It made a graph that's wider, or in other words, we have a vertical compression because we're squashing it from, or pulling it, actually we're squashing it from the top down. Compression, can't spell it, there we go. And it makes it wider. The blue graph you see here is 3x to the third. Now when you have a number in front of x that's bigger, 3x to the third, it gets way more narrow. In other words, it makes it thinner. We have a vertical stretch. Oops, stretch. I wish I could spell today, but it is our first day back. So basically, if you have a number in front, a vertical stretch means like if I grab your head and your feet and I pull them apart, that would effectively make you thinner, if not be painful in the process. The green line here, the 1/3, the fraction is like if I got your head and your feet and I pushed them towards each other with a lot of force. That would make you shorter and make you shoot out to the sides more. So that's kind of the effect that having the number in front of x cubed does to you. Now what we're going to do, for example, one on the right-hand side is, it says make a table, and we will do that, but on the side over here, I'm going to go ahead and erase where it says table, and then make a prediction about what my graph should look like. I know my basic parent graph, the one I had on the first page, was a nice graph that goes up from the bottom, hits 0, and then comes up like that. That would be my basic parent graph. But in this equation, I have x minus 2 to the third power. So I have to predict what's going to happen. My prediction is going to be that since I have minus 2 in parentheses, I suspect I will have a shift of 2 units to the right. Because when I'm subtracting, although I want to think moving left because it's minus 2, remember in parentheses, whatever you see in there, it's the opposite. So minus 2 is going to mean shifting 2 units to the right. So I would suspect I have, instead of an origin at 0, it should have moved 2 units to the right, and it should be right here at positive 2. And I'm going to go ahead and work on verifying that down here. So what I'm going to do at the bottom is I'm going to first create a new table, x and y, make some columns. And in the middle, I'm going to put the equation they give me for this example. The equation I have for this one is x minus 2 to the third power. So I'm going to go ahead and pick some numbers. Now, I will show you later on how to get really good numbers. Just use my examples for now. The numbers I want to use for this, because my graph has been moved over, I'm not going to pick a lot of negatives. I'm going to start with 0, 1, 2, 3, and 4. So what I do first is I take 0 minus 2 to the third power. 0 minus 2 is negative 2, so I have to figure out what negative 2 to the third power is. Then I'm going to go 1 minus 2 to the third power. 1 minus 2 is negative 1, and then figure out what that is to the third power. Then I'm going to do 2 minus 2 to the third power. 2 minus 2 is 0. 0 to the third power for sure is going to be 0. Then I'm going to take the 3 minus 2 to the third power. 3 minus 2 is positive 1 to the third power. And then I'm going to have 4 minus 2 to the third power. 4 minus 2 is 2 to the third power. So let's get all these answers. Negative 2 to the third power means negative 2 times negative 2 times negative 2 again. Negative 2 times negative 2 is positive 4 times negative 2 again is negative 8. Negative 1 times negative 1 times negative 1 will be a negative 1. Positive 1 times positive 1 times positive 1 is a positive 1. And then 2 times 2 is 4 times 2 is 8. So here are my points. I have 0, negative 8. So that's my first point. 0, negative, now negative 8 doesn't really fit. If this is 5, this is 6, 7, 8 would be about down here. It would be about right here. So I would have a point here. I'm going to just pretend that this is negative 7, and this line right here is negative 8. Let's pretend like my line goes further down. My next point is at 1, negative 1. So I go positive 1 to the right, and then down 1. So this point shoots up pretty fast. My next point is at 2, 0, just like I predicted. My next point is at 3, 1, right here. And then my final point is at 4, 8. So I go right 4, 6, see right 4, 6, 7. It'd be about right here. This is it right there. So to connect all my points, I get something like this. Let me move my graph up so I can get it all to fit a little better. So it'd be something like that. And that's exactly what I predicted. I have the parent graph that shifted 2 units to the right. Everything moved over 2 squares to the right. So there's the basic graph. It is sloppy because my screen is so huge and I can't fit it all in one. I can't get the whole picture in one screen, in one frame. So it's a little hard for me to get the perfect graph, but I think you guys get the idea. Let's continue on. So now we have another graph here. Example 2. I have x cubed minus 2. I don't have any parentheses, so since there's nothing in parentheses, there will be no translation. At least I don't expect any from the left or to the right. I do at the very end, though, have a minus 2. I predict that that should shift the graph, or the parent graph, 2 units down. 2 units down, because it's minus 2. So let me explain what that means. If the parent graph of y or f of x equals x cubed looks like pretty much like this. It's going to be coming up, it curves, and then shoots up. That's your parent graph. We suspect that this new graph will shift the graph down by 2 units. That means I don't expect a movement left or right, but the origin should just drop down to right here. So what we're going to do is make a table again. I'll try to fit it right here on the side just to keep the graph in view. In the middle, I'm going to have the equation x cubed minus 2. The numbers we're going to use for this are going to be -2, -1, 0, 1, and 2. Because it goes right through the origin, I need some negatives and some positives. On the last graph, it was shifted to the right, so I needed more positive numbers. Since I'm right in the middle, I need a little bit of both. So let's start with 0. That's always the easiest one. 0 to the third power is 0. -2 is a -2. So 0, -2, bam. I already predicted it was going to drop down 2, and that shows it right there. -1 to the third power is -1. -2 more is -3. So I go -1 to the left and then down to -3. So there's a point right there. -2 to the third power is going to be a -8. -2 more would be a -10. It's not really going to fit on my graph. It'd be way the heck down here somewhere. So I'm not even going to bother putting it on the graph. 1 to the third power is 1. -2 is a -1. So I'm going to have to go to, 1 to the third power is +1. Yeah, -2 is going to be -1. So I go to 1, -1, so it's going to go right here. Then I go to 2. 2 to the third power is 8. -2 is 6. So when I put in a 2, I get a 6. So what I have is a graph that's going to go pretty much something like that. So my first graph was a little bit too wide, but the red graph, the second one, was a little more accurate. So our graph did shift down 2 units. That's what we see here, and that's what the effect was. Now let's predict over here for number 3. Now you can graph all these on your calculator to get a better view, but I'm going ahead, since I'm not in the mood right now to switch back and forth too much, I'm going to go ahead and just do them all rough. Plus you guys don't always have a calculator at home. Now, I have a couple of predictions to make here for this one. First thing, I have this negative sign in front, which means instead of my graph going up like this from left to right, it's going to do the exact opposite. I suspect it's going to be flipped over the x-axis and do that instead. So my first prediction is that it's going to be flipped over the x-axis. In other words, the graph will be decreasing. It's going to be getting smaller from left to right. It's going to go from positive land to negative land. Second prediction, right here, the +3. That +3 means I'm going to shift 3 units, but not to the right. It's going to be to the left instead because it's the opposite of what it looks like. It's going to go shift these to the left. So instead of having my graph coming down the middle, like I see here, it's actually going to move over 1, 2, 3, and it should come through a point over here, and then come down something like that. Of course, that's a little bit over dramatic. That's my next prediction. My final prediction is this +2. That means it's going to be shifted 2 units up. So instead of being on the x-axis down here, it should actually go up 1, 2 to right here, and I should have a line that comes through like this for my final answer. So I'll go move that point. I'm going to try to draw a better one. I predict that I will have, I'll just use dashes as my prediction, something that kind of looks something like this, but maybe not as sloppy. So let's go ahead and make a table below to see where we actually end up. Now for my table, I'm only going to pick a few points because this grid is really small, so it's hard to get a lot of really good points. So I'm going to go ahead and make my X and my Y column. In the middle, I'm going to have the negative x plus 3 cubed plus 2. I'm going to pick -4, -3, -2, and -1. Because my graph was shifted to the left and into the negative side of the graph, I'm going to use more negative numbers. So I have minus -4 plus 3, which is going to be -1, times -1 is +1 to the third is still +1, plus 2, and that's going to give me a 3. When I plug in -3, if I do all the math, I get a 2. When I plug in -2, I get a 1, I believe. Let's see, -2 plus 3 is 1, negative 1, comes a negative 1 again, I believe. Let me double check this really quick. Yeah, I believe with negative 2, you're going to get a positive 1. And then with negative 1, you get a negative 6. So let's go ahead and see how this is going to look on my graph. So at negative 4 on the left side, I go to positive 3. 1, 2, 3. So all right there. Use a different color to differentiate negative 4. So that it almost actually ends up on my prediction dot. Then I have at negative 3, I go to, it's supposed to be positive 2. Yes, negative 3 is positive 2, right there, where I predicted also. Then I have at negative 2, I drop to positive 1, so it kind of goes like that. And then at negative 1, it drops all the way down to negative 6. So my graph wasn't that far off. My prediction actually worked pretty decently. You get a curve that basically looks like that. All right, not too bad. Now, the domain and range of this graph is different. Whoops, let me erase that. It's different from the original ones. Yes, it's going to have the all real numbers, but it's going to be in reverse order. If you read this graph from left to right, you discover a couple of things. The domain is still the same. It goes from negative to positive infinity. So that's still good. But the range is different. The range goes from positive infinity down towards negative infinity from left to right. So it's still all real numbers, but it just goes in a different direction because it's decreasing. So that's what changes here. The domain will still be the same. The range will change if you have a negative in front of your equation. Now we have 2x cubed and negative 1/2 x cubed. These two I'm going to leave for you to do, but we're going to go ahead and make our predictions. The predictions will tell you how it should look after you do graph it. So 2x cubed. The 2 in front is a number that's bigger than 1. So what we're going to have is the same graph, but it's going to be stretched. It's going to be stretched or it's going to be squashed. Positive 2 is going to make it skinnier. So in other words, what I'm going to do is if I take your head and your feet, and I pull them apart, that's what we call a vertical stretch. So it's going to be a real thin graph that shoots up and down really fast. You probably won't be able to get too many points on there. For number 5, my prediction is going to be, since I have this negative 1/2, there's going to be 2 predictions. It's going to be flipped. And it should also be wide. Wide means I took your head and your feet and I vertically compressed them. Push them towards each other. Like if you're in a trash compressor. All right, so I should get a graph that is going to be going, for example, something like downwards but wider. That's way over dramatic, but it's going to be wider than normal. This one should just be still positive but really skinny and shoot up pretty fast. So go ahead and make your own table for these two, graph the points, and show me what you get. I will recommend some points for these ones. The points I want you to use for these tables are going to be, let's see, I'll set it up for you. Here's your x values. The x values I want you to use are negative 1.5, negative 1, negative 1/2, or negative 0.5. If you use decimals there, 0, 1/2, positive 1, and positive 1.5. Show the work. The equation you're going to plug in is 2x cubed. So show the work, and then show what you get for your y value. Over here on the other side, we're going to use a lot of the similar same points. We're going to begin with negative 2, negative 1.5, negative 1, negative 1/2, 0, 1/2, 1, 1.5, and then 2. Plug in the numbers into the equation. The equation you're going to use is negative 1/2 times x to the 3rd power, and then give me your y values. Get the points and plot them. All right, so there's your lesson for today. It is pretty extensive. I'm sorry for that, but that's the ropes. Best of luck on this lesson.